Hey, sir, how's it going?
Doing all right. How you doing?
Pretty good.
Excellent.
Did you have a good weekend?
Yeah, always.
Good.
All right, folks, you ready?
Ready as I'll ever be.
All right.
Do
Let's
it.
start with this exam number 7. I think most of y'all did fairly well on this. All right, number 1. If you travel 65 miles an hour, how many feet can you travel in 22 minutes? One way to think about this is like think about your units, right? Uh, 65 miles per hour, you're looking at a length per time. They want to know how many feet. So we're looking for a length, but they give you a time, right? If you take a length per time and multiply it by a time, you're left with length. It's one way to think about it. Another way to think about it is they're giving you minutes and we have to convert that to feet. And this is our conversion factor. They're saying 65 miles is the same as an hour. And then we have 22 minutes that we have to transfer to feet. So if you want to, you could do 22 minutes, right? But we want to convert that to feet, knowing that, um, let's see, 65 miles is the same as an hour. So this is our smart one. This is just a big number 1 right here. All right. And you see we have time over time. The time will go away and leave us with length, but we need length in feet. So what we can do, well, let's just convert. Let's get rid of hours in favor of minutes. 1 hour is 60 minutes, right? It's the same thing as if we just replaced hour here with 60 minutes. Now our minutes are gone, we're left with miles. But what we want is feet. So let's get rid of miles in favor of feet. And there it is. 5,280 feet make a mile. So miles are gone. We're left with feet like we wanted. So now we just have to do the arithmetic here. We have 22 times 65 times 5280 divided by 60. 125,840 feet. So number 2, do it the same way. The child requires 4.5 milliliters dose of medicine each day. How many days would a cup of this medicine last? Well, if 4.5 milliliters was a tenth of a cup, well, then it would last 10 days, right? So basically, we're just dividing 4.5 milliliters into 1 cup. Taking 1 cup, dividing it by that. That's what kind of goes through your head if you just try to, like, do it in your head. But if we're going to do it, doing conversions the way we did number 1, let's say it's more complicated where you couldn't just do it in your head. We could use the same principles. They're saying you have a cup, and then we have to convert 1 cup to days, and 4.5 milliliters is equivalent to 1 day, right? They're saying this is the same thing. We start off with a cup, 1 cup, but we want to convert that to days. So we're going to have to get rid of cups. We want cups on the bottom and we want to end up with days on the top. So we know that 1 day is the same as 4.5 milliliters. This is a smart one. This is our conversion factor. Basically, it's just what I wrote down a while ago. 1 cup divided by 4.5 milliliters. But, using the concepts of unit conversion and smart ones. So what we need to do here is turn milliliters into cups. We want to get rid of milliliters, but they don't have milliliters to cups. We can go milliliters to fluid ounces and then fluid ounces to cups. 8 fluid ounces make a cup, and we have 29.6 milliliters make 1 fluid ounce. So we go from milliliters to fluid ounces and get rid of fluid ounces in favor of cups. We're left with days. So now we just have to do our arithmetic. 29.6 times 8 divided by 4.5. Well, this is an approximation, right? Because this is a approximation here. So 52.6 days. Any questions about that? Just converting units here. All right. No questions. We'll move on to the quiz here. Need y'all to solve for X. Let's see. 3 O's. Take 15. Take a few more minutes for this one. Let's say it's if it's 310, then 325. We'll get back together. Okay. Let me put you in your breakout rooms. All right, class. Before we solve the quiz here, there's a question on the last one up here. Somebody asked if we should round up to 53 or not. Well, if it was simply rounding, yeah, that would round up to 53. But considering it's medication and do you want to buy 52.6 days worth of medicine to last 53 days? You know, if anything, you'd want to round down to 52. At 4.5 milliliters a dose, 1 cup won't last 53 days. It'll only last 52.6.
Excuse
So
me,
if you're going to
Professor.
round your medicine, I'd round down to make sure that you have more than enough, right? Does
Excuse
that
me,
make
sir.
sense?
Can you hear me?
All right.
Can you read your messages?
Yeah, I see you there. That's fine. You can get the exam off the lecture notes. I'll post them right after class.
All right, thank you very much. I just wanted to let you know I was leaving.
All right, get well, man. Okay, so let's knock out this quiz here. Number 1. So we got our X in 2 different locations here. So the first thing I'd want to do is get rid of these parentheses. So in order to do that, we need to distribute the minus sign through there. We have a negative 3x and then a negative 2. So that's a plus 2. So 5x minus 3x is 2x. All right, now we can get this 2 off of the 2x. So we'll subtract 2 from both sides. So 14 minus 2 is 12. It's 2x. So now dividing both sides by 2. 12 over 2 is 6. Let's check before we move on. Check. All right, the left-hand side is 14, right? So our right-hand side, if we plug a 6 in for x, we get 30 minus 18 minus 2, which is 30 minus 16, which is 14, which is the left-hand side. So we're good to go there. All right, let's look at number 2. Any questions about number 1? All right. So let's see, we have this big O fraction over here. So let's get rid of the fraction first. So if we multiply both sides by 6, okay, that'll get rid of that big fraction. See, 6 times 4, we got a negative 24x. Over here, the 6's go away. We have a 5 times a 1 minus x. All right, now that we got rid of the fraction, let's get rid of these parentheses here. Multiply the 5 through. We have a 5 times 1, and then a minus a 5 times x. All right, now let's get our x's together. We can add 5x to both sides. Like that goes away. And let's see here. Negative 24x plus 5x is a negative 19x equals 5. Now we can divide both sides by a negative 19. So we have x is a negative 5 over 19. All right, let's check our work. Check. All right, our left-hand side is negative 4 times x. So this would be a positive 2019. That's the left-hand side. So let's look at the right-hand side now. We got a 5 times a 1 minus x. X is a negative 5 over 19. Over 6 here. So that's our right hand side. If we plug negative 5 over 19 for x, so we have 5. Let's see, let's rewrite 1 here as a 19 over 19. The minus minus becomes a plus. So we have 19 plus 5 is 24 19ths. This is all over 6. So we just pull our 6 right here. So we could multiply this out, but let's take, to simplify the fraction, let's see, 24 is 8 times 3. And 8 is 2 times 2 times 2. So all I did was take the 24 here and write it like that, just so I could simplify this fraction. Because 6 here is 3 times 2. So I got a 5 times 2 is 10 times 2 is 20 and 19 on the bottom. That is the left-hand side. So check. All right, any questions? All right, moving on. So we're on page 55 now. We're going to slowly get towards graphing functions. All right, so here's your XY coordinate system. This is your x-axis. This is your y-axis. They give you a coordinate x and y. So the first one is how far you go left or right. The second one is how far you go up or down. So if X is positive, you go to the right. So you'd be over here somewhere. If X is negative, you'd be over here somewhere. If Y is positive, you're up here. If Y is negative, you're down here. They take these, they number our quadrants. This is number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Okay, that's how they like to label our quadrants. Notice they go counterclockwise. So for instance, if you want to graph a point like say 1, 2, you go to the right 1 and you go up 2. Boom. That would be the coordinate 1, 2. So first coordinate is left and right, second coordinate is up and down. And here's our quadrants, just a way of locating stuff. So they're asking us about our quadrants here. All right. If an X coordinate is positive, in which quadrants? Well, if X is positive, we're over here, which means we're in quadrants 1 or 4. All right. Negative, if X is negative, then we've gone to the left. So you're in quadrants 2 or 3. Now, Y coordinates, if the Y coordinate is positive, that means we've gone up. So you're either in quadrant 1 or 2. And if your Y is negative, you've gone down. So you're either in quadrant 3 or 4. All right, we're going to plot some points here. So 2, 5, we go to the right, 1, 2, and then we go up 5. 1, 2, 3, 4, 5. So boom, there is 2, 5. Negative 2, negative 5, we go to the left 2, and then we go down 1, 2, 3, 4, 5. So that would be negative 2, negative 5. Notice how these are related, you know? So 7, negative 3, we go to the right 7 and go down 1, 2, 3. So that's 7, negative 3. Negative 4, 6, we go to the left 4 and then we go up 6. 1, 2, 3, 4, 5, 6. Negative 4, 6. It's easy enough, right? So far? It's no more difficult than playing Battleship. All right, plot 0, 5. Well, the X is 0, so that means you're not going right or left at all. But we are going up 5, 0, 5. We go up 5. Boom. 0, 5. Notice that point is lying on the y-axis. So we would call that a y-intercept because it intercepts the y-axis. 0, negative 5. We don't go left or right. We go down 5. So there's 0, negative 5. So that's also on the y-axis. We call it a y-intercept as well. 0, negative 1. We don't go left or right. We just go down 1. 0, negative 1. Now 0, 9. Don't go left or right. We go up 9. 0, 9. So all of these have 0 for their x's. And they have different y's, but they all lie on the y-axis. So these are all y-intercepts. That's what those are called. Okay. These, notice they all have 0 for y. That means they're all going to lie on the x-axis. So they're all going to be called x-intercepts. 2, 0, we go to the right 2, but we don't go up or down. So that's 2, 0. Negative 2, 0. Go to the left 2, don't go up or down. Negative 7, 0. And 6, 0. All right, they all lay on the x-axis because all their y values are 0. So they're all x-intercepts. All right, now we're going to practice putting things in this form. Y equals mx plus b. So this equation, notice there's 2 variables now, not just one. Okay. So when we used to only have one variable, we'd solve it and we'd end up with like x equals 2 or x equals 7. There's only one solution to the equation. But now that there's 2 solutions, two variables, the solutions to this equation, there's an infinite number of them. And they come in coordinate pairs, an x and a y. So the solutions might look like 1, 2, or 6, negative 3. They might look like that. Okay. But there's an infinite number of them. But if you take all the solutions to this equation and plot them all, you're going to end up with something that looks like a straight line. So like all these could be the solutions to this equation. So our goal here is when we rewrite this thing to be in this form, it helps us, we can look at it in this form and more easily see what the line is. So this line would be a visual representation of the solutions to this equation. So people who like pictures more than numbers or letters, if you put it in this form, it's easy to know what it looks like. So that's why we're doing that. Notice over here, if you make x 0, so if x equals 0, then your y is whatever b is. So for example, over here, if we take divide everything by 2, we have y equals 3/2 x, 8/2 is 4. So here our m is 3/2 and our b is 4. So what that tells us, if we wanted a solution to this equation, we would just rewrote it like this. If x is 0, then y is b, which is 4. So 0, 1, 2, 3, 4. That point there, that is one solution to this equation. If you plug in 0 for x, you will get y equals 4. The m tells you the slope. Okay. So m is the slope of the line. They call it rise over run, or the change in y over the change in x, or y2 minus y1 over x2 minus x1. So what that means is here the slope is 3/2. So that says rise over run. That means if we go up 1, 2, 3, and then we go to the right 2, 1, 2, this point right here is also a solution. And now that we know 2 points, we know all the points. So if we went up 3, instead at 4, we're at 7. And we went to the right 2, instead of 0, we're at 2. 2, 7 is also a solution. We can use the slope to see what the line looks like. Notice the slope here is positive. This is a line with a positive slope. This is a line with a negative slope. This is a line with a 0 slope. So this tells you, the B tells you where it intersects the y-axis, or the y-intercept. The M tells you the slope. So they call this a slope-intercept form. Now this is just a glimpse as to why we're gonna do this. All right, we're gonna get into this in more detail later, but for now, let's just practice getting stuff into y-intercept form. Now that you have like a hint of why we're doing it. I don't want to do 20 problems without knowing what the purpose is. So we want to get this into y-intercept form. Let's divide both sides by a -3. That gives us y equals 3 over -3 is a -1x. -9 over -3 is a +3. So here m is -1 and b is 3, right? The m is whatever you're multiplying the x by. Let's look at number 7 here. Okay, so let's subtract 2x from both sides. That gives us a 3y equals -2x plus 15. Now we can divide both sides by 3. We have y equals -2/3 x plus 5. So our m here is a -2/3 and our b here is 5. Okay. Okay, let's to get the y by itself, let's take 3x from both sides. So we got -3y equals -3x plus 9. Now we can divide by a -3. Y equals -3 over -3 is just 1. 9 over -3 is a -3. Who can tell me what m is here?
-1.
Yeah,
Here, what are we multiplying x by?
1.
Exactly. It's just 1. It's 1x. We just don't write the 1, right? Now what is our b?
-3.
-3. Exactly. Put 9 here. All right, this guy, we just need to multiply both sides by a -1. So we have y equals a -2x minus 1 times 1. So what is our m?
-2.
-2.
That's right. And our b is
-1.
precisely. All right. All right, to get y by itself, let's take 5x from both sides. So we got a 15y equals -5x minus 15. Now we'll just divide both sides by 15. So -5 over 15 would be a -1/3, right? I'm gonna write it like this. And then -15 over 15 is 1. So what is our m here?
would it be 5?
What are we multiplying our x by?
$15.
No, here's our x.
-x/3.
-1/3, right? -x over 3. That's the same thing as -1/3 times x, right?
How would you go about graphing a fraction like that? If you're going to put it on the graph, how would you do that?
No, it's just the way you'd think. If this is 1, this is 2, this is 3. If you want 1/2, it's going to be right here. That'd be at 1/2. Or you could be like This is 1, this is 2, and this is 3. So this is 1/2. See what I mean?
That's a lot more simple than I thought it was going to be.
Yeah,
Thank you.
sure. So our m here, looking at this, remember we're y equals mx plus b. M is the thing we're multiplying the x by. B is the thing that's being added to it. So B is a -1. All right. To put this in y equals mx plus b or slope intercept form, let's see, let's get 6x away from each side. So we got a -3y equals -6x plus 18. Now we can divide by -3, y equals 2x minus 6. So what is our m? Tell me what-
2x.
That's 2. And our b is -6. There's one with a bunch of fractions in it. These are just numbers like any other number. All right, so let's subtract a half an x from both sides. So we got a -2/3 y equals -1/2 x plus 4. Now multiply both sides by a -3/2. So that goes away, and those cancel. Gives us y equals. We multiply this times this, we get a negative make a positive 3/4 x. -3/2 times a positive 4 would be 12/2, which is just 6, right? So our m here is 3/4. Our b here is a -6. All right, let's get our y by itself. Let's subtract a half an x from both sides. We have a 2y equals -1/2 x plus 6. Now we can divide everything by 2. Y equals a half divided by 2 would be a 1/4. And 6/2 is 3. So m is -1/4 and b is 3. M and b. Let's see, let's take this guy, let's multiply both sides by 2. So we got x plus y equals -6. Now we can subtract x from both sides. We got y equals -x minus 6. So what is our m here?
-1,
That's right. And our b is?
-6.
Very good. All right. Let's get y by itself. Let's subtract 1/3 x from both sides. And -2y equals -1/3 x plus 2/3. Now divide everything by -2. We have y equals A negative 1/3 divided by 2 gives us a positive 1/6. And a positive 2/3 over a negative 2 gives us a negative 2/6, which is 1/3, right? So what is our M here?
M
1/6.
is
No,
6.
1/6. And what is our B?
B is 2/6.
Yeah,
Negative 2/6.
negative 2/6 or negative 1/3, same thing, right?
Um,
All right, to get Y, let's subtract half an X from both sides. We got a 3/4 Y equals negative half an X plus 3. Now let's multiply both sides by 4/3. We have Y equals a half times 4/3. That's 4/6. And then plus 12/3. The same thing as this. 12 divided by 3 is 4. So what is our M?
Negative 4/6
Yeah,
or negative 2/3.
yeah, same thing, right? And what's our B?
4.
B4. You sunk my battleship. So they're going to give us a bunch of numbers. They're going to give us an A, B, C, and D, and they want us to figure this out. All right. The reason why we're going to do these is because it's for finding the slope. If you have 2 points, you can find the slope. Let's say here's a point and here's a point. Let's call that point X1, Y1. Let's call this point here X2, Y2. So if we want to find M, which is the rise over the run, the rise is this distance here, right? That's how far you're going up. So what is the rise? Well, if this distance here is Y2 and this distance here is Y1, then that distance there is Y2 minus Y1. So a rise is the difference in the Y coordinates. And the run, that's between the 2 points. That would be right here. This is your run, right? So there's your rise, there's your run. So this is your X2, this is your X1. So right here, you take your X2 and you subtract your X1 and you get that little middle piece, X2 minus X1. All right, so that's a way of getting the slope when you know 2 points. So we're going to practice just doing basic arithmetic first. So here's A, B, C, and D. They want an A minus C over B minus D. A is 10, C is 4. B is 7, D is 5. 10 minus 4 is 6, 7 minus 5 is 2, 6 over 2 is 3. That's a slope of 3. So that means if this is a point on your graph, you go up 1, 2, 3 and go to the right 1. So your line would look like that, because this is the same thing as 3 over 1. Your slope is 3. So That's what a slope of 3 looks like. The slope of -3 would go down like that. A slope of 100 would be like that. A slope of like 0.25 would just barely be uphill. So the bigger the slope, well, the taller the hill. The smaller the slope, the smaller the hill.
Did you say 3 as an example, or where did you get 3 from?
I'm sorry, can you say that again?
I said, did you get 3 as an example, or where'd you get 3 from?
From this A minus C over B minus D. I just plugged in these numbers into the formula that they asked. So yeah, I'm just using 3 as an example for a slope. If 3 was the slope of some equation, it would look.
Oh, okay.
I'm getting ahead of myself, but I just want y'all to have an idea of where we're going with this. So A minus C over B minus D. A is 5, C is -3, B is -7, and D is 9. Right here is where most people mess up. It says A minus C. A is 5, and we have a minus, and C is a -3. So 5 minus -3 is 8. And then we have a -16. So this is a -1/2. All right. Let's get a new page for this one. This one has a bunch of fractions. A minus C over B minus D. A is 1/2. C is 5/2. B is 1/3. D is a -5/6. All right, so on the top, since we have a common denominator of 2, we can just subtract. 1 minus 5 is a -4. On the bottom, we don't have a common denominator. So we'll multiply this 1/3 by 2 over 2. On top, -4 over 2 is a -2. The bottom, we have 2 over 6 plus 5 over 6. All right, that was why we multiplied by a 2 over 2, was so that we'd have a 6 on the bottom. That way we can combine these. 2 plus 5 is 7/6. Now, instead of dividing by this fraction, that's the same as multiplying by its reciprocal. This gives us a -12/7.
I'm not understanding where the 2 comes from.
This one,
We're multiplying, no, where you multiply 2 over 2.
oh, right here.
Mm-hmm.
All right, we want to add these. We're trying to combine these fractions, right?
Yeah.
But this one has a 3 on the bottom and this one has a 6. We wanted them to have the same thing on the bottom. So when you multiply by 2 over 2, 3 times 2 is 6. Right?
Okay.
This is just the number 1, but it's a smart one so that we can turn 1/3 that's turned into 2/6.
Okay.
That way we can add these fractions.
Okay. Thank you.
Here's another ugly one. Fractions. A minus C over B minus D. We got a -5/7 minus 2/3 over 2 minus 2/3. All right, on top, we don't have a common denominator. So we're gonna make one. Since this has a 3 and that one has a 7, I'm gonna multiply this one by a 3 over 3. And I'm gonna multiply the second one by a 7 over 7. So notice they both have 21 on the bottom now. They have a common denominator. Now on the bottom, we need a common denominator again. I'm going to multiply this 2 by a 3 over 3. So now they both have 3's on the bottom. So up here we have a negative 15 over 21 minus 14 over 21. Then we have a 6 over 3 minus 2 over 3. So since we have common denominators now, negative 15 and a negative 14 give us a negative 29 over 21. 6 minus 2 is 4. So we had negative 29 over 21. So instead of dividing by this fraction, we're going to multiply by its reciprocal. So let's see, what's 29 times 3? 29 times 3 is 87. Yeah, 87. Then a 21. Actually, instead of doing that, let's take this 21 and rewrite it as 7 times 3. So we got a negative 29, and 7 times 4 is a 28. All right, it's 4:05. Let's take a break. Come back at 4:20. Yeah, see y'all soon. All right, class, welcome back. It's 4:20. Hope y'all aren't busy doing something you're not supposed to be doing. Wait till after class at least. All right, 21. More fractions here. All right, what was it? A minus C over B minus D. A is 8, C is 8. B is 3 and D is a negative 2. This gives us 0 over 5. How many times does 5 go into 0? Exactly 0 times, right? No problem. 22. A minus C over B minus D. Negative 7 minus a negative 1 over 4 minus 4. This gives us negative 6 over 0. What happens when you divide by 0?
You get 0.
Kinda. Let's think about it this way. Let's just take 1 here and divide by 0.00001. Right? If you divide by something small, you get something big, right? But let's say I divided by something even smaller. If I divide by something even smaller, I get something even bigger, right? So I'm going to use some notation here. I'm going to put 0 plus. And what I'm saying here is I'm saying a number that's not 0, but it's so close to 0, it may as well be. But it's a positive number. All right. So what I'm saying here is plug in numbers that are smaller and smaller and smaller and smaller, getting closer and closer to 0, and they're all positive. So 1 divided by something teeny, 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 tiny is going to give you something huge. All right. So I'm going to say that 1 over 0 plus gives you a positive infinity. The smaller the number you divide by, the bigger number you get. So closer and closer to 0 on the bottom, that gives you closer and closer to infinity on the top. But now what if we did the same thing, but instead of, let's do this. Divide by something teeny tiny but negative. That's something negative but big. And if I make it even smaller on the bottom, I get something that's negative but bigger. So if I take that and use 0 minus to denote something that's so close to 0 but negative, right? You're going to get a really huge number, but it's negative. I should have put this plus sign on the other side. It's positive infinity. Okay, So what we're saying here is 1 divided by 0, it's equal to both positive and negative infinity. Can you see that? But infinity is not a number, but if it were, you couldn't get two numbers further apart than positive and negative infinity, right?
Right.
So this would be a positive negative infinity, which doesn't make any sense. So we say this is undefined. All right, you cannot divide by 0 unless you're happy with working with positive negative infinity as being the same thing. There's abstract mathematics where you can do that, where you treat your number line, you take your number line here and you bend it in a circle and you connect one end to the other end. So if this is positive infinity and this is negative infinity, this point here would be both positive negative infinity, and you're working in some kind of weird ass circle world. But we're not doing that here. All right, this is algebra. So you work with infinities in calculus. We find ways of doing that in calculus. In calculus, geometry, you find areas of squares, circles, triangles. But if you have some weird object like this and you wanted to find the area of it, you'd break it into a bunch of rectangles. And you know the areas of rectangles, right?
Yep.
And so on. So you add up the areas of all the rectangles, but you're off by this much every time, right? But if you make your rectangles really, really, really skinny, all right, there's less error. So what you do is you take this as I'll use W, the width of your rectangle. All right. You set up your formula. So it's an area. It's just the sum of all the areas of all the rectangles, and they all depend on W, the width of your rectangle. And then you let that go to 0, and the formula spits out a number. You end up with like zeros over zeros or infinities over infinities, but all the infinities and the zeros on the bottom all cancel out, and you actually end up with a number that's exactly the area of this stuff. So that's what you do in calculus. It's not hard. It's just algebra with a little trick called limits. But you don't have to deal with that today. Just remember, you cannot divide by 0, because if you do, you're getting both positive and negative infinity at the same time.
Big letters don't divide. Thank you.
Yeah. So yeah, all that was for those people celebrating 420 there. All right, number 23. All right, we just discussed that. Let's put that up here. Boom. Discuss. This is for later. All right, linear graphs. We're on page 59 now. Intercepts method. So all our linear equations look like this. Those equations we've just been taking and putting into y equals mx plus b form. Okay, that's there's two variables. All right, so they can all look like this. You can put them all into this form. All right, if you wanted here, you could subtract ax from both sides. You'd have a by equals negative ax plus c divided by b, and you have y equals negative a over b x plus c over b. So our m would be a negative a over b, and our b would be capital C over capital B. All right, the point is if you got an x and a y, it's a linear equation. They're just saying a, b, and c here are numbers. So 2x plus 3y equals 4, linear equation. 3y minus x equals 7. You got an x and a y. This is a linear equation. It's called a linear equation because if you take all the solutions and graph them, they would make a line where every single point on that line is a solution. Okay, so let's look at these. Which ones of these are linear equations? This one is, there's an x and a y. What about this one? Where's the y? Technically, what if I put in here 0y? I could put that there, right? So there is an x and a y. It just happens that the letter in front of y is 0. So go up here. If I made b 0, it says a, b, and c are real numbers. 0 is a real number. So yeah, that's a linear equation. This one, the x is in the exponent. Oh no, that doesn't fit this. You don't see an x in an exponent. It has to just be a number times x. This guy here, the x has a exponent on it. This is an x squared. So no. The reason why is if you graph the solutions to that, instead of being a straight line, it's going to be a curved line. Okay. So what if I had like a 3y equals 2? That's a linear equation because I could just be like, oh, there's 0x here. So there's x's and y's. It's just the coefficient for the x is 0. So that one would work as well. Linear equations. Oh, this guy. For this equation, the point 6,1 is a solution because if you take the 6 and plug it in for x and the 1 in for y, the left-hand side equals the right-hand side, right? 6 and a 1, 6 plus 2 is 8. Does that make sense? All right, it's not the only solution. There's an infinite number of solutions. So here's another one. Show that -2, 5 is also a solution. If I plug a -2 in for the x and a 5 for the y, I get 8, which is the other side of the equation. So we know 6,1 is a solution. We know -2, 5 is a solution. Check this out. 1, 2, 3, 4, 5, 6. Oh, and up 1. -2, 1, 2, up 5, 1, 2, 3, 4, 5. We know those 2 points are solutions. 2 points make a line. So that line there is a visual representation of all the solutions for this equation. Some of our favorite solutions are the ones where they cross the axes, the intercepts. And we find those when we let one variable or the other be 0, which I think is what we're going to do next. Yeah, let's do that. So can we find another solution? Those are the 2. Well, one way to do it is I can just look at the graph, be like, boom, there's a solution. 0, 4. Here's another solution. 8, 0. I can look at the graph and tell you. Or I could do it mathematically. If x is 0, then if we plug a 0 in, we get 2y equals 8 or y equals 4. So 0, 4 is a solution. Or if I let y be 0, I plug a 0 in right there, I got x equals 8. So 8, 0. Isn't that exactly what we saw over here just by looking at it? Those happen to be the intercepts. But here's a point. Let's see, -6, +7. That's a solution too. If I plug in -6 for X and a 7 for Y, it will satisfy this equation. So there are an infinite number of solutions to these linear equations. And this line over here is a visual representation. Okay. Notice if we put this guy in y equals mx plus b form, let's do that. We'd have 2y equals -x plus 8. So y equals -1/2 x plus 4. So our m here is -1/2 and our b is 4. That b shows up right there. That b is our y intercept. Because if you plug in a 0 for x, you're just left with y equals 4. That's why we like to put it in that form. Because just by putting it in this form, we already know that, oh, there's a 4 there. Oh, well, here's a point on my graph. The slope here is -1/2. Because it's negative, that's why it's going downhill. It says if I go down 1 and go right 2, I'll be on a point on the graph. If I go down 1, go to the right 2, boom, point on the graph. Down 1, right 2, down 1, right 2, down 1, right 2. That's why the slope is nice. So if you know B, you're like, boom. And then I see -1/2. Oh, if the line goes down like that, it gives you an instant visual representation whenever you see it written like that. So that's the purpose of all this. I've already told y'all the x-intercept of a line is the point where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Find the x and y intercepts. Well, here's one. That is 0, 8. That's the y-intercept. So this is the y-axis. This point is -5, 0. That's the x-intercept. Notice y is 0 here and x is 0 here. What about this dude? It crosses right here, 0, 0. This is both the x-intercept and the y-intercept. It's the origin. That's the only point on the graph that's on both the x-axis and the y-axis. And what about this guy? Looking at this, it's going uphill. I can tell you that m is positive. We got this and this. That point there is what, 0, -3.5. This point up here is a 5, 0. This is our 5, 0. This is our x-intercept. This is our y-intercept. Just looking at the graph, I can tell you what the formula is. Y equals mx plus b, right? That right there is our b. Actually, it's 3.5. 3.5. Well, -3.5. That's our b. So -3.5. So we got something here. Notice if I plug a 0 in for x, I get -3.5. So what would our m be? Well, if I go up 3.5 and I go to the right 5, I'm on a point on the graph. So our slope here is 3.5 over 5. It's our rise over our run. We're just taking 2 points here and we're looking at the change in, they write like this, the change in y over the change in x. So our y's here are 0, minus a negative 3, 5, and then our changes in x's are 5 minus 0. So that's why it's 3.5 over 5. That's our slope. So this is the actual equation for the line that they just gave us here. So you can go from equation to line, or you can go from line to equation. Find the intercepts. All right, number one, to find the intercepts, first, if x is 0, then y is 9. We know that because it's in mx plus b form. So therefore, 0, 9 is a solution. It happens to be our our y-intercept. Y-intercept. Where is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. 0, 9. It's on the y-axis. That's our y-intercept. And now, what if we let y be 0? If we let y be 0, boom, we got 0 equals negative 2x plus 9. Or negative 2x equals a negative 9. Or x equals 9 halves of 4.5. So 4.50. When x is 4.5, y is 0. This is our x-intercept. So let's see, 1, 2, 3, 4, 5. We want 4.5. This is 4.50. That's our x-intercept. That line is all the solutions to this equation. All you need is 2 points, make a line. Those are the easiest two to find, the x and y intercepts. What about this guy? Well, if x is 0, then y is 6. So 0, 6. 1, 2, 3, 4, 5, 6. Boom. 0, 6. That's our y-intercept. But if y is 0, then our equation says 0 equals 6 plus x, or x is negative 6. So negative 6, 0, negative 6, 0 is a point on the graph. 1, 2, 3, 4, 5, 6. We don't go up or down. That's negative 6, 0. That is on our x-axis. That's our x-intercept. Now we know 2 points. Draw a line through it. There's all of our solutions. We could rewrite this as x plus 6 instead of 6 plus x. What is our m here? It's 1, and our b is 6. The b always tells you the y-intercept. Boom. That's b. Our slope here is 1. That means if I go to the right one and up 1, I'm still on the graph. 1 over 1 is the same as 6 over 6. If I go to the right 6 and go up 6, I'm on the graph. So a slope of 1 is 45 degrees upward. A negative 1 would be 45 degrees downward. So now you can recognize if you have a slope between 0 and 1, it's upwards. But if it's above 1, it's above the 45. Okay. 45. So this is m less than 1, m equal to 1, m greater than 1. Okay, if we let x be 0, then 12y equals 6. which says that y is a half. So 0, 1/2. Oh, that's curvy. 0, 1/2. This is our y-intercept. If we let y be 0, boom, then negative 2x equals 6, or x equals negative 3. So negative 3, 0, negative 3, 0. 1, 2, 3. This is our x-intercept. We've got 2 points. We can draw a line through them. Those are all the solutions. Before. All right. If x is 0, boom, then 5y is 17. So y equals 17 fifths. So 0, 17 fifths. This is our y-intercept. 0, 17 fifths. Or if we let y be 0, boom, then 8x equals 17, or x equals 17 over 8. So 17 over 8, 0 is our x-intercept. Somewhere over here, 17 over 8, comma 0, that's our x-intercept. Those are all our solutions. Sketch the graph of a line that does not have an x-intercept. Here's our x-axis. How about this line? If it doesn't cross the x-axis, then it's parallel to it. I could call this y equals 2. So the solution to the equations y equals 2 is this line. Part B here, if it doesn't have a y-intercept, then it's parallel to the y-axis. I could call this x equals 2. Every point on here has an x coordinate of 2. All right, let's sketch this graph. Let's see, if we multiply both sides by a 2 fifths, we have y equals 20 over 5 is 4. Y equals 4. If we're going to graph this, 1, 2, 3, 4. That's y equals 4. Notice this point here is 0, 4. 1, 2. This point here would be a 2, 4. 1, 2, 3. This point here would be a negative 3, 4. Every single point on that line has a y value of 4. It doesn't say anything about x. So x takes on all possible values, and that's how you get a line. This one's similar, except y isn't mentioned. If we divide both sides by 8, we got x equals negative 2. 1, 2. This is x equals negative 2, the line. Remember how we used to just solve these? They'd say solve for x. We go, there's our answer. Yeah, it's just a number. But if you're thinking of this as an equation with 2 variables where one variable isn't mentioned and you want to visualize it, it's this entire line. So this point right here is a negative 2, 0. This point here would be a negative 2, negative 2. 1, 2, 3, 4. That point there would be a negative 2, 4. All the possible coordinates where x is negative 2 give you this vertical line. All right, write an equation of a line with y-intercept 0, 5. Okay. Y-intercept 0, 5. So don't go right or left, go up 1, 2, 3, 4, 5. Boom. 0, 5. We want an equation of a line that goes there. How about this one? Boom. Y equals 5. That's one of them. But think about y equals mx plus b. What if I did negative 2x plus 5? If I plugged a 0 in for x, I get y equals 5, right? This one would look kind of like that. Or I could do y equals 3x plus 5. If I plug a 0 in for x, I still get 5, right? 0, 5 is a solution. I plug 0 in, I get 5. Basically, anything of this form, plug in any number you want for m. If I make x 0, then y is 5. So that's how you get all possible lines through that point. Mx plus 5. Just remember the b here, that is the y-intercept. Any questions? Okay. I think this is where I left off in the last class. So let's see here. Here is your exam number 8. And I will see y'all on Wednesday.
Okay, sir. Have a good one.
Too.
Have a good day, sir. Thank you.
Mhm.